Hello everyone, my name is Helfert Pasaribu. I'm a student at Geothermal Master's Program ITB. This time I will present paper presentation for ITB International Geothermal Workshop 2022 with title Heat Source Identification by Reprocessing Geoscience Data to Update Conceptual Model in Pentadio Geothermal Prospect Area. Pentadio Geothermal Prospect Area is located in Gorontalo City, Sulawesi Island, Indonesia. As you can see, the main feature on this area is Limboto Lake, located in the middle of prospect area. Preliminary study was involved in this area and reported in Geothermal Potential book by Energy and Mineral Resources of Indonesia. The main purposes of this paper or the previous studies show that the geothermal system is influenced by magma intrusion in the bottom of Limboto Lake as its heat source. So, in the report of Badan Geology, they said the heat source on the system is an intrusion. But in the geothermal system, magma can be a heat source if the magma is in age of active or recent magmatism age. But this area have not or does not show the intrusion magma that have active or recent magmatism age. So it is necessary to review and reprocess the data that has been taken previously to be able to define what is the heat source on the system. The data that we use in this paper is three main data. The first one is geothermal regional map. Second one is water geochemistry from thermal manifestation. And the third is gravity survey data. All of data is secondary data. So we have to say the data is valid and represent the subsurface condition. First, geology. The Pentadio geothermal prospect area is a part of North Sulawesi Arc. The North Sulawesi Arc, there is a big fold, northwest, southeast. And the andesitic lava on this area was formed in Miocene period time and had lost its heat for a long time ago. So there is no chance for an intrusion from Miocene period to be a heat source in this area. So geophysical survey is needed to define the potential heat source of the system. Because the main problem is there is no geology feature that can define another heat source. So this is a medium enthalpy or medium temperature system that the geophysical data is truly needed to define and give explanation about the subsurface. And from geochemistry data, we have two parts of thermal manifestation. The first one is the north of Limboto Lake. The second one is the south of Limboto Lake. The thermal manifestation in this area is plotted into two parts based on its geothermal or geochemistry. As a chemical, we can see the ratio of chloride and sulfate to chloride carbon. You can see the first one is a chloride sulfate, and the second one in the south of Limboto Lake is a carbonate water. So we can see the differences, the difference of these two manifestations. If we can see the ratio of chloride, lithium, and boron, you can see the chloride water, chloride has a higher concentration from this manifestation, and there is no lithium there or boron, and lithium show the leaching process, so there is no leaching process, and boron can show you the influence of volcanism. There's no boron here, there's a little near to chloride, because the concentration of chloride is higher, a lot of higher than lithium and boron. From temperature, north of manifestation in the north of Limboto Lake has a higher temperature. It's 74 to 78 degrees Celsius. But the second one is it's cold water below 30 degrees Celsius. And you can see the manifestation that we can calculate as geothermometer is only this 4 manifestation, because there's a high temperature and have a chloride sulfate water type. But the problem is, Nicholson say that chloride sulfate can be represent the reservoir temperature, but because we only have this 4, so we can say the temperature of reservoir near to 150 degrees Celsius. If we can see this in this diagram, the 4 of manifestation is a partial equation, and the manifestation on the south is high magnesium that not represent to reservoir situation or reservoir condition. The third one is gravity survey. As you can see, this one is gravity survey from the potential book, and in the right is the gravity survey that was digitized from this picture. So we can get the grid and numeric model from this grid. The depth estimation on this area for residual is only 2 to 3 kilometers. It's quite good enough because the reservoir may be only on 2 kilometers below the surface. This is the residual map from gravity. As you can see, the thermal manifestation in this area appear to be controlled by fault leading to northwest, and southeast. The reservoir zone tend to be just below of Limboto Lake, this area, maybe in the west, on the west side of fault, and the north and south is bounded by basin fault. After that, we do inversion to get a 3D model. We build the model parameter, and we do fault modeling. The observed data is input, as needed input, and the model with the fault modeling, we can do inversion to get a model or solution. Then the model is visual in A.L.F.A. This is how the model is defined or visual in A.L.F.A. As you can see, there is a topography on this area. Is flat in the middle of survey area. It's likely like a basin, and then there is a giant fault, regional fault, and this one may be the reservoir because it's have low density. Low density, so maybe it's contain the water or the fluid, so have lower density than the compact rock or formation. From this model, we can see the reservoir is located in the below of Limboto Lake, and the fluid from the manifestation in the surface is came from reservoir from the permeable zone and uplift to the surface. The second thermal manifestation in the south of Limboto Lake is from the near surface, so it's not from reservoir, but it can help to define the system. So the next question is, what is the heat source of this system? From this conceptual model, we built the conceptual model of this result by using the geology regional section, geothermal method of water chemistry, and the gravity model. And the reservoir of this area is sealed by a layer. We see a layer with a pressure fluid through the permeable. So this layer make a pressure, so to make the fluid is uplift to surface. The heat came as heat flux that triggered by the presence of regional fault. The area of Gorontalo Graben. So this is the role of this basin is as a brown boundary of the system, and it's permeable. It's not a fault, but it's a contactuality. So we need to drill this area. If you want to get a reservoir, you have to drill in the middle of Limboto Lake. But I think it's so difficult because we have to build the rig on the top of Limboto Lake. But with this recent technology, I think it's possible. So the conclusion of this paper is the heat source of this area, not the intrusion, but it by heat influx. that triggered by regional fault, not by the intrusion of the tertiary lava. The reservoir located in 1.5 to 2 kilometers in subsurface is likely 150 degrees Celsius temperature. And I think to validate, we have to drill, or maybe the next research is about to do isotope study. The number of gravity survey, it's quite good enough, but we haven't data in the middle of Lake Limboto. I think it's we need to make survey to define the system, or maybe to validate if there is a new intrusion in the bottom of Limboto Lake. The bathymetry survey maybe can help in gravity correction, but I think it's not produce a lot of differences. Maybe it's just likely differences. We need to take the data on the middle of Limboto Lake. That's it. That's my presentation. Thank you for the committee. See you.
Hello, everyone. My name is Fathoni. I'm going to present our paper with the title of Identification of Volcanostratigraphy Units using Topography and Digital Elevation Model Analysis and its implication to geothermal exploration in Waesano and the surrounding area is Nusa Tenggara. The author of this paper is myself, Fathoni, after Pasaribu, Leticia, Soetjahjo, Nasir Huda, Betseba, Sibarani, Zafira Abdillah, and Suryantini. The studio area is located in the West Manggarai Regency, Nusa Tenggara Timur Province, Eastern Indonesia. Geothermal system inferred to be related with volcanic activity under the Sanongguang Lake. The purpose of this study is to identify the volcanostratigraphy units in the study area and its implication for exploration. In this study, we are using two types of data. The primary data consists of 8 Landsat 8 imagery, DEMNAS, and topographic map. From this primary data, we derive NDVI and elastic morphological characteristics such as slope and relative elevation, landform roughness, and catchment area. The secondary data consists of geological map and thermal manifestation that are derived from previous research. These data were then combined to derive the volcanic units that present in the area. Then we find the implication for geothermal exploration from the volcanostratigraphic units. The implication that we're trying to find is what influenced the occurrence of the thermal springs, how the volcanostratigraphy could help geothermal exploration, and surface thermal anomaly for additional ground check. The geological setting in the study area are dominated with volcanic activity. There are several formations that are found in the study area, which are young volcanic products, old volcanic product, coastal terrace, tufaceous limestone, berry formation, bedded limestone, Nangapanda formation, and Kiro formation. The oldest volcanic deposit that found in the area are Kiro formation that deposit during Middle Miocene to Late Miocene and Pliocene. The next volcanic activity then assumed to happen during the Pliocene to Pleistocene, which deposit the old volcanic product. Then it was continued with deposition of young volcanic product during the Late Pleistocene. The old volcanic product and young volcanic product cover most of the study area. Young volcanic products are presumed to be the product of mountain Waesano, while the old volcanic products are presumed to be the product of Mount Belling. This is the result of the volcanostratigraphic units identification in the study area. The volcanostratigraphic unit that forms consists of 5 brigades. The second brigade located in the northwest of the study area. This brigade was identified by the presence of circular feature that presumed as the remnant of caldera rim. Belling Brigade located in the northeast of the study area and east of the Sengan Brigade. Belling Brigade consists of 1 crown and 3 hummock, and 1 circular feature that presumes a caldera rim. Soetjahjo Brigade located in the southwest of the study area. Soetjahjo Brigade consists of 2 crown, 1 hummock, and 1 circular feature that is presumed to be a caldera rim. Mendeler Brigade located in the west of the study area. Mendeler Brigade consists of 4 crowns, 2 circular feature that is presumed to be caldera rim. Waesano Brigade located in the center of the study area. Waesano Brigade consists of 2 crown and 2 hummocks. These products, volcanostratigraphic units, are assumed to be date around quarter with absolute age identified for the Waesano Brigade ranging from 0.3 to 0.1 million years ago. From NDVI analysis, this area could be divided into 3 categories of value. Values that are less than 0.2 are identified to be related with the highly stressed vegetation area. Value of ranging from 0.2 to 0.6 are indicating the slightly stressed vegetation area, while the healthy vegetation area are identified at the value of more than 0.6. From the analysis, it was identified that there are presence of several anomalies that could be seen from the NDVI. These anomalies mostly located in the Waesano Brigade, while several could also identified in the Belling Brigade and Sengan Brigade. These anomalies are recommended for further checking. Implication for the geothermal exploration from the volcanostratigraphy perspective. First, we've seen that the distribution of thermal spring are only located at the Sanongguang Crown and Golondaring Crown. These thermal springs in the Sanongguang Crown show temperature that reach 80 degrees Celsius, while the Golondaring Crown only reach around 40 degrees Celsius. This thermal spring distribution is in accordance with the result of the preliminary volcanostratigraphic study that classified that the Sanongguang Crown as the youngest volcanic stratigraphic unit. This could limited our study area for exploration into the Sanongguang Crown and the Golondaring Crown to the northeast of the study area. Then, thermal spring only present in the east catchment area. This indicates that there are no thermal that influence the groundwater on other catchment area. It is correlate with the volcanostratigraphy unit, which are present in the west of the study area or consist of old volcanostratigraphic units. However, the presence of the thermal springs that only occurs at the center of the northeast part of the catchment area indicates that there are other control which limited the distribution of thermal in the study area. Then, finally, there is a possibility of thermal residue from the volcanic activity in the Golondaring Crown. In the Golondaring Crown, there are presence of rectangular drainage pattern, which also show a dense network of river. This indicates that possibility of a high structure control area, but the Golodaring crown manifestation only show a 0.1 liter per second debit output, which are relatively small. This show that there is other control than structure that found in the that control the Golodaring manifestation, which also show that the occurrence of this manifestation is happen located in the hummock of this crown, which indicate that there are a possibility of thermal residue from volcanic activity of this crown, this hummock. Conclusion: application of volcanostratigraphy during the preliminary analysis is proven to be helpful to localize the exploration area and understand the possibility of factors that influence the geothermal system in the study area. In the study area, 5 brigades are identified, namely Sengang Brigade, Beling Brigade, Sokaka Brigade, Mendeler Brigade, and Waesano Brigade. High temperature thermal manifestation are identified in Sanonggoang Crown, which indicates the presence of heat source in this crown. One manifestation at Golodaring Crown is probably influenced by volcanic thermal residual and structure geology that presents in the area. This is my reference. That is all of my presentation. Thank you for watching and for your attention. Bye-bye.
Thank you for the opportunity. Let me introduce myself. My name is Amerensia Soetjahjo. I am from ITB Geothermal Master Program, and it's such an honor to becoming a part of ITB Geothermal International Geothermal Workshop 2022. Now I will present a paper about common sensing analysis to determine the secondary mineral occurrences near thermal manifestation at Kotamobagu Geothermal Prospect Area. There is outlines in this presentation. It is introduction, background, geology, remote sensing method, in this case normalized different vegetation index, land surface temperature, band rationing, result and discussion, and the last one is conclusion and suggestion. Okay, to the first one, it is introduction. Remote sensing itself is the science of acquiring, processing, and interpreting images and related data acquired from aircraft and satellites that record the interaction between matters and electromagnetic energy. Remote sensing itself images are used for mineral exploration in two applications. The first one is to mapping geology and the fault and fractures that localize ore deposits and recognize hydrothermally altered rocks by their special spectral signatures. Remote sensing itself is the art and science of obtaining information about an object without being direct physical contact with the object itself. Remote sensing can be used to measure important geological features in the surface. This paper discusses the application of remote sensing techniques, which is NDVI, LST, and band rationing, in this case Kotamobagu Geothermal Field and Mount Ambang as the specific area. The background of this paper is remote sensing analysis were used for an early stage to identification mineral exploration, especially in area that geographically difficult to access. It is also how to assess the remote sensing data in geothermal area. It also discuss about how to integration remote sensing data and other geoscience data, and the correlation between remote sensing techniques result, in this case, NDVI, LST, and band rationing. It is the location of the study area. the study area location of study area is Kotamobagu. The width of Kotamobagu geothermal prospect area is around 1,355 kilometer square and administratively registered in Minahasa Selatan, Kotamobagu, Bolangondu Regency, located in North Celebes province in Indonesia. Approximately 200 kilometers southwest from Manado City, which is the capital city of the province. It has been proved that this field is one of the geothermal prospects in Indonesia. The geological map was shown in the slide. The area is covered by neogen and quaternary rocks. The neogen volcanic rocks are the product of old volcanoes and consist of breccia, tuff, andesitic lava, dacite, and rhyolite from Mount Simut and Mount Lemibut, located to the north of Mount Moayat. The quaternary volcanic rocks consist of old and young ambang volcanic. Tuff pumice and andesitic breccia are the products of old ambang volcano. The breccia overlain asymmetrically by Mount Moayat and Mount Bangga and Mount Ambang. It is basically by Rio Gilang 2012 and 2013. Faults in Kotamobagu area are associated with the occurrences of thermal manifestation. Fault from northwest to southeast associated with the existence of a marl at the top of Mount Moayat, which have temperature around 102 degrees Celsius. Another fault from west to east is associated with sedimentary rocks and control the appearance of hot spring manifestation in Bakan and Pusian, which located at the southwest and south of Kotamobagu geothermal field. We came to data and method. Data were used. In this research is Landsat 8 OLI tiers from USGS Earth Explorer. In LST and NDVI processing, we were used Landsat 8 OLI tiers data, but since Sabin ratio in band ratio method, we used Landsat 7 for the processing. The data itself was converted from Landsat 7 to Landsat 8 in the same wavelength. For example, you can see the table in the left side of the slide. It is the SWIR wavelength, and Landsat 7, it is band 5, which number 1.547 to 1.749. And in Landsat 8, the SWIR band with 30 meter ground is 1.566 to 1.651. So while using the data, we can conclude that the band 5 is similar with band 5 in Landsat 7 is similar with band 6 and Landsat 8. So the data from Landsat 7 we convert to Landsat 8 OLI tiers in the same wavelength. We came to normalize different vegetation index, and this NDVI itself were calculated from satellite images, data with 30 meter ground resolution. For research study area was covered in Kotamobagu area using near infrared and red band from the Landsat 8 data. For research study area was covered by one scene that occurred on 20 and 21 with relatively cloud-free in the area. And the equation of NDVI is NDVI equals infrared band minus visible red band divided by infrared band plus visible red band. The calculation for NDVI, like I was mentioned before, is equals NYR minus red divided by NYR plus red, or NDVI equals band 5 minus band 4 divided by band 5 plus band 4, where red in this equation, red is equals to digital number values from the red band, and IR equals digital number values from near infrared. It is basically by Rose, 1974, developed the generic normalized vegetation index And the NFVI is functionally equivalent to the simple ratio. The equation is like I was mentioned before. Land surface temperature. Land surface temperature, or LST, is the radiatively temperature of Earth's surface. The Earth has an average temperature of about 15 degrees Celsius, with temperature ranging from minus 25 degrees Celsius to 45 degrees Celsius. The LST is radiative, which calculated using top of atmosphere, which calculated using top of atmosphere bright temperature. Wavelength of emitted radiance and land surface emissivity is LST equals BT to BT, or bright temperature, divided by 1 plus lambda times bright temperature, divided by C2 times natural logarithmic of E, while C2 is equals to 14,388 micrometer K, and the value of lambda for Landsat 8 for band 10 is 10.8, and band 11 is 12.0, where the lambda is the wavelength of emitted radiance, E is land surface emissivity, and H is Planck constant, S is Boltzmann constant, and C is the velocity of the light. We came to band rationing. Band ratio is dividing a pixel value or digital number in one band by digital number in the other band. So basically, it takes pixel whose absolute digital number, values, or radiance that might be very similar. For example, if they are very high, but when you take the ratio of two bands, those pixels may have a different value. So it can magnify, and turns out this technique is essential for overcoming shadows and any kind variable reflector that we might be seeing in our field. Image enhancement alters the visual impact that the image has on the interpreter. The objective is to improve the information content of the image itself. For example, you can see the picture in the right side of the slide that show the difference before and after we using band ratio in study field. We came to the result from NFVI LST band ratio and the map of expected alteration area. The first one is normalize the different vegetation index. The comparison between NFVI in the right and true color composite in the left shown that the NFVI anomaly area was in particular area with orange to red color, while in true color composite show anomaly caused by water, shadow clouds, or even man-made feature. In this case, water body, city, roads, or another. This area shall not be interpreted as NFVI anomaly area. After removing the area which are not caused by thermal process, we can indicate that the other anomaly is from correlated with the thermal manifestation activity in the Mount Ambang area. The true color composite anomaly were caused by water body, like I was mentioned previously, water body, shadow cloud, and man-made feature, and did not also count as the NFVI anomaly. The yellow reddish area indicates as the anomaly with manifestation existence. The 0.1 value indicates vegetation stress. The 0 value indicates water body in this area. The water body in red color, it is Moat Lake. We came to the land surface temperature or LST. The LST map shown the anomaly temperature respectively areas that are characterized by high temperature that could represent area that are constantly hot. In the study area, in this case Mount Ambang, showing anomaly thermal that has temperature about 22.7 degrees Celsius to 24.7 degrees Celsius. It is shown in a map in orange to yellowish color. This area also not considered as the man-made area since it has low NDVI anomalies like what I was mentioned previously. We came to Bendocasio, the result of Bendocasio. It is the color composite image in blue, green, and red that's shown in ratio 6 divided by 7, 4 divided by 2, and 4 divided by 6, respectively, using Landsat 8. A combination of Bendocasio was applied to enhance the allocation mineral spectral signature using Bendocasio, developed by Sabins in 1999 of red, green, blue. The ratio itself is third divided by 5, third divided by 1, and 5 divided by 7 in Landsat 7, and was modified, and we modified to red, green, blue. And the ratio is 6 divided 7, 4 divided 2, and 4 divided 6 in Landsat 8. To recognize recognition of hydrothermally altered rocks that may be associated with the mineral deposits. In this case, you can see in the map it was color blue to greenish. So we indicate it is the alteration mineral, clay and alunites that occur in hydrothermally altered rocks. This is the alteration map. The area of Mount Ambang was delimited with pinkish color because of this area had all the anomalies, which is in this case expected mineral hydrothermal alteration, vegetation or unhealthy vegetation, vegetation stress or unhealthy vegetation, and thermal anomalies. We came to the conclusion of this paper. Remote sensing has proven several areas with thermal anomalies, which is vegetation stress and expected hydrothermal mineral Mount Ambang. Hydrothermal mineral Mount Ambang, its crater is one of the several areas and also had all the anomaly. NDVI mean unhealthy or stress vegetation, or while anomaly temperature means standard deviation that may suggest anomalies of an area. Some of the area are not possible to detect hydrothermal alteration because of the vegetation. The anomaly of NDVI explain area that may be the road of past fluid that may not have been seen in true color composite map. Hydrothermal mineral occurrences, in this case clay and alunites, are expressed using wavelengths that are undetectable by the eye. Image interpretation will produce a map of localities prospect with a condition for mineral deposits. The suggestion from this paper is remote sensing result can also be used for the ground studies to prove true condition of the surface. According to the data anomalies in Mount Ambang, ground checking in the field work was needed to prove is there any correlation with geothermal activities. Also, another method can use to improve the result of this research. This is the reference that I have been used for this study. Thank you for the attention. Now I will stop this presentation. Thank you. See you in the next year.
Hello everybody, I want to present my paper about preliminary study on geothermal system interpretation using volcanostratigraphy and geomorphology approach, like a study Graho-Nyabu geothermal prospect area. So it's my paper outline, introduction, methodology, geological setting, result and discussion. Composed of volcanostratigraphic analysis, structural geomorphology analysis, and magnetotelluric data analysis. The summary and references. The introduction and the active manifestation in Mount Sumbing as a steaming ground and indicated as a geothermal system. The interpretation of geothermal system can be assessed by using geomorphology and volcanostratigraphy approach. Volcanostratigraphic analysis in this research area needs to be done because it can help with interpretation, especially the possibility of heat source in this prospect area. Structural geomorphology analysis, particularly morphology, which is controlled by structural geology, can be used to interpret the possibilities, permeability, and geothermal system in a sectoral or more detailed. The methodology, the first volcanostratigraphy study was conducted to observe a volcanic unit by integrating regional geological maps, DNAS, and data on geothermal manifestation of the surface in this research area. The interpretation of geothermal system can be assessed by using geomorphology and volcanostratigraphy approach. The volcanostratigraphy unit were determined by identifying topographic map with scale of 150 then for more detailed information. So for the topographic map of 100 scale, the bracket, crown, and hammock were identified. The crown is generally corrected by the contour pattern of the volcanic crown, but the lineament and circle feature can be clear and detailed in the specifically topographic map. Was the geological setting, the geological structure in the study area has a general direction of northwest southeast. We can find in the northwest southeast lineament, and the northeast southwest we can depend in the north minor structure and north southeast intercept. The stratigraphic in this research are based on Kusmana is quaternary rock QHPN and the QTP located in near of this research area and detailed in the Masurai, Sumbing, and Hulunilo. So the pre-tertiary rock find in GA and PP or Pelpat formation find the northeast of the research area. So the result and discussion is the volcanostratigraphic analysis based on 100 scale. Based on the analysis, we find Merangin bracket. So this one is Merangin bracket. We have the Masurai crown. This Merangin bracket is a coverage of this area. This Masurai crown, Mergu crown, and rest is Tumbang crown in this area. So we can find in the west area is the Hulunilo crown and the Sumbing crown. The direction of the younger eruption can identify to the north east direction for the area, and the northwest direction to the young organic. Because in the scale, we can detail the volcanostratigraphy, the Hulu crown and the Sumbing crown. And the stratovolcano with cone is still quite clear indicate, and the center of eruption may indicate to the heat source in Sumbing crown. We have steaming ground manifestation. The correlation of our volcanostratigraphic unit, we determine the relatively edge is the quaternary, but the period of activity in this research area in 1909 or 1921 more A-type volcano. The Sumbing crown is the younger volcano. So, and is the result structural geomorphology analysis. Based on the structural geomorphology analysis, the Graho-Nyabu geothermal project area is divided into 4 sectors. A, B, C, D is the 4 sector. Relatively on the west of the volcanic complex. The sector is near Great Sumatran Fault, and we have one sector on the flank of Sumbing volcanic mountain. The structural geomorphology analysis and the geothermal system of Mount Sumbing in the sector 1 is associated a volcanic system with an echelon fault. That's one, maybe this an echelon fault, the control of volcanic system in Sumbing Tron. The B is a extensional strike slip duplex, an effect of display of a Great Sumatran Fault, but we have the mixture in this area has a manifestation steam ground and steam ground and hot spring in this area. But the sea is near the Great Sumatran Fault. The splay of the Sumatran Fault, the extension and hostile splay is the manifestation warm spring in this area, and the last is the sector 4 is extensional hostile splay with an excellent. So the result and distribution of magnetotellurics, the magnetotelluric survey is evenly distributed in the Graho-Nyabu prospect area, only in the manifestation area and alignment of Masurai volcano, Hulu Nilo, and Sumbing. The section of G1, G1 is the section Masurai, Hulu Nilo, and Sumbing. Northwest southeast direction is the low resistivity value of less than 4 meter is red color. Is interpreted as the conductive layer and thickness toward the northwest. The under of monsoon beam, we find low resistivity like a plumbing structure in the subsurface, interpreted heat source because it supported by occurrence of steam ground in the surface. The empty modeling of G3 section with southwest northeast extent of the geothermal system, but in the under G3 section, especially in the manifest line, is no low resistivity that indicate this heat source in this area. Not in the low resistivity, but in the more deeper magnet low resistivity. They indicate the heat source low resistivity. We not found it's indicated the heat source is maybe deeper heat sweep. So same the G3 case in the magnetotellurification of G4. We have the thick layer in the northeast, but in the central of the area we found maybe a barrier of the geothermal system on the chip. Also, the summary in the distribution of volcanostratigraphic unit with 100 scale, the marine rates unit is obtained, and the Masurai cron, Tumbang cron, Mercu cron unit, and smaller that 2 cron were the Blue Nilo cron and CD. Based on structural geothermal analysis, there are 4 geothermal sector with a field sector as a geological structure associate interpret as the effect or splay with Great Sumatran fault, and one sector associated with volcanism and geological structure in the Mount Sumbing. Based on empty data, low resistivity value less 10 ohmmeter were obtained along the subsurface of Mount Masurai, Mount Hulu Nilo, and Mount Sumbing, indicating the presence of conductive layer in this area in the section northwest southeast. So this is my presentation. Thank you very much for your attention.
Okay, hello, my name is A.L.F.A, and this is my paper about operation excellence, the implementation of Land Six Sigma to maintain production facilities of geothermal power plant. And this is the outlines of my presentation today. And this is the chapter 1, the introduction of the geothermal potential resource in Indonesia. It is about 24 gigawatt, and only 2 of gigawatt, or around 9% of this resource were developed. And as a result, we need to understand more about the obstacles of developing geothermal resource in order to compete with fossil or other energy resource. And this is the step of geothermal development along and complicated of geothermal development and operation procedure. And the most GPP maintenance methods are based on maintenance technique used in traditional power plant, such as thermal and hydroelectric plants, manufacturing and service sectors, as well as suggestion from equipment suppliers contained in maintenance manuals. And this is the table 1, the geothermal production and transmission equipment. This is our process is production and transmission, and we have the main equipment is wellhead, separator, and steam transmission, and then the water transmission. And the main component of this equipment is valve, pipe, and then flow meter, etc., etc. And when we're implementing a preventive maintenance method, equipment downtime and maintenance costs must be kept to a minimum. And the data from the schedule and unexpected shutdowns is also a consideration for review. And as a result, it is predicted that all sub-business processes would execute optimally while incurring the lowest operational expenses. And the chapter 2 will talk about the field, general field superintendents. And it is described as an area responsible for all field operation and maintenance operation. And the general field superintendents is separated into two sections, which are the well superintendents and surface facilities superintendents. And the well superintendents is the charge of all activity related to construction, repairs, maintenance, or control of the underground part of the wells. And it's dividing into the drilling groups and the repairs group. And the second one is the surface facility superintendents, which is the responsible for all activities related to the operational and maintenance of the well surface facilities. And it's subdivided into construction and surface maintenance group, operation group, and study group. And this is a methodology of this journal. We have the MIC methodology, which is the standard for define, measure, analysis, improve, and control processes. It's a standard of framework phrase for adapting Six Sigma in the pursuit of operational excellence. As a result, a systematic process review from identifying obstacles to tracking improvement results becomes the guidelines. And Lean Six Sigma uses the MIC in making process improvement. And from the MIC, we will know about the fishbone diagram, or FMAA, the failure mode and effect analysis for the steam gathering and transmission equipment. For example, if we talk about valve of various type and size, such master valve, service valve, etc., separator, and the cause of and effect of this diagram in figure 5 depicts the FMEA for the system and equipment. The graphic depicts probable failures, causes, and consequences. And if we talk about this paper, we will know a discussion about the FMEA and the MIC itself. The FMEA analysis show that the most of maintenance problem in GPPs are related to chemical and physical properties of the geothermal fluid itself. And then for the MIC framework will be utilized regularly to ensure that the best outcomes are achieved at every level of the business process. And from this dissection, we will have result for the installation of implementing the operation excellence, which is the first is to reduce costs and to improve the safety condition, to increase the equipment and capacity, efficiency or reliability, to simplify the operation. And then to improve the condition to provide maintenance, to reduce failure, to improve the operating condition of the equipment, and the last one is to increase the equipment's lifespan. So the equipment will have more long lifetime if we use this method to the GPP's equipment. So modifying the installation of replacing a piece of equipment with a better feature set are example of improvements. And after the result, we have the conclusion of this paper is the GPP maintenance costs account for a considerable portion of the unit cost of geothermal energy, and we have an impact on the plant's profitability. And then the high expenses of developing and sustaining current management principle have restrict their use in GPPs. Furthermore, there is a widespread aversion among GPP's maintenance employees to experimenting with and adopting novel concept. And this is the conclusion of if we implementing the what I say, the implementing of the operation excellence for GPP's geothermal power plant for the next step of maintenance. And then I say thank you for everyone, and thank you for everything, and goodbye.